when we have a trinomial that comes with a leading coefficient, like the one that we saw, when we have a number in front of the x squared. What we've done in the previous example is to group those two together and take out the GCF from those two terms. The constant term at the end has nothing to do with the first square. We don't need to complete the square. You will only be using the first two terms in your trinomial to complete the square. When it comes with a trinomial, that gives us a number like this. We will still be doing the same thing. It is not easy to deal with fractions, but we need to work on them anyways. So similar to what we did, we are going to take out the GCF from the first two terms. Leave it outside the bracket. Leave it at the very end. Take out the 1/3 from the first two terms. And the plus 10, keep it at the end. For those of you who wonder how I came up with -12, yeah, you times that. You know you are taking out 1/3. When you want to take out 1/3 from a constant term, it will be the same as multiplying the 4 and the 3 together. Well, technically, 4 divided by 1/3. When you are to take out 1/3 from this number, it will be the same as having 4 times 3/1. That's how I end up with the 12x in the middle. Once I take out the GCF from the first two terms, we can then come up with a perfect square. As we're having 12x in the middle, divide this term by 2. When you divide it by 2, that's how you end up with 6. And we will square it to complete the square. This is what we have f as a new term. In order to offset the change, we will undo it at a later time. And we will subtract it by this many times. Now here is your quadratic function in vertex form. The 3 terms inside the bracket will now give us a perfect square. The rest of it will now give us the number at the end. -2. You use your calculator to find the value. This is plus 10 minus 36 divided by 3. When you times it by 1/3, that's the same as working with a division. So this will give us a parabola that opens this way with a minimum point at -2. For the next example, if we have 0.25 at the beginning, I can rewrite this equation to -1/4. And we will now complete the square by taking out the GCF it comes with a negative, and there is a quarter in front of your x squared. If this is what we factor out from the first two terms, The plus will now turn into a minus. And the 2x, when you take out a quarter from it, it will now give us 8x. Why is it negative 8? When we factor out the negative from a plus, we have 8 instead of. To recreate the plus is 8. When we factor out the negative from a positive, it will give us negative. And the 8 here comes from the fact that we divide this by 1/4. Divided by 1/4 will be the same as 2 times 4. That's how I end up with this fifth term. We can then come up with a perfect square. You need a perfect square inside the bracket to complete the square. What is the number that should go here? 4 squared, yes. You want to add 4 squared inside the bracket. You can use a 16, that's fine. 4 squared will be 16. And if you are adding 16 inside the bracket, you will then be subtracting 16 by that many times, which will be the same. But the reason why I'm not using 16 here is because I will be using the number from the above to create the perfect square. If I will be using the 4 in this perfect square, why would I square this number and then you have to go 4? Do that. That's fine. That's fine. So long that you know what you're trying to get, that's fine. And then the rest of it, it is plus 3 plus 4, so that will give us a plus 7. This will give us a quadratic that opens downward, compressed vertically by a quarter size, and it will give us a maximum point at 4 and 7. So here, it happens, the maximum point happens when x equals 4.